So welcome to this session on sampling distributions. We will learn how to calculate the probable limits and standard error and how to check if a given hypothesis is unbiased or not. So let n be the sample size, p be the probability of success, q be the probability of failure. Let x be the observed number of successes and mu be the expected number of successes. Let z equal to modulus of x minus np by root npq. So if mod z greater than 2.58, we conclude that the difference is highly significant and reject the hypothesis. We also need to remember the formula for probable limits, which is p plus or minus 2.58 into root pq by n. So where p is the proportion. So coming to the first problem, a coin is tossed 1000 times and head turns up 540 times. Is the coin unbiased? So let p be the probability of getting a head. P is half. Q is also half. An expected number of heads in 1000 choices will be np, that is 1000 into half, which is 500. Actual number of heads is given to be 540. Difference is 40. So your z will be mod 40 minus 500 by root npq, which is 2.53, and z alpha is 2.58. Since 2.53 is less than 2.58, our assumption is true, so the coin is unbiased. Coming to question 2. In 324 throws of a 6-faced die, an odd number turns up 181 times. Is it reasonable to think that the die is unbiased? Let p be the probability of odd number. So what is p? Half, because you get odd numbers, 3 odd numbers. Expected number of successes is np, which is half into 324, which is 162. What is your observed number of successes? 181. So z is mod x minus np by root npq. Substituting, you get 2.11, which is less than 2.58. So what do? We accept the hypothesis. And what is the hypothesis? The die is unbiased. Now note this formula for probable limits. P plus or minus 2.58 root pq by n, where what is root pq by n? It is also called the standard error. Coming to the next question. A random sample of 500 apples was taken from a consignment and 65 were found to be bad. Estimate the proportion of bad apples and the standard error of the estimate. Also find the percentage of bad apples. So P is 65 by 500, which is 0.13. Just change this to 500. What will be Q? 1 minus P, which is 0.87. Standard error is root PQ by n. So substituting, you get 0.015. So what are the formula for probable limits? P plus or minus 2.58 root PQ by n. Substituting, you get 0.13 plus or minus 0.0387. which is 0.0913 and 0.1687. You want to find the percentage of bad apples. So multiply by 100. That will be 9.13% and 16.87%. Coming to the next question. A survey was conducted in a locality of 2000 families by selecting a sample of size 800. It was found that 180 families were illiterate. Find the probable limits of illiterate families in this population of 2000. So P is 180 by 200, which is 0.225. What will be Q? 1 minus P, which is 0.775. So probable limits of illiterate families is given by the formula P plus or minus 2.58 root PQ by n. Substituting, you get 0.187 and 0.263. Now what do you need to find? The probable limits of illiterate families in this population of 2000. So multiply each by 2000. So you get 0.187 into 2000 and 0.263 into 2000, which is 374 to 526. Coming to the next question, that is the last one. In a location of 18,000 families, a sample of 840 families was selected at random. Of these 840 families, 206 were found to have a monthly income of 2,500 or less. Estimate how many of the 18,000 families have monthly income of rupees 2,500 or less. within what limits will you place your estimate? So P is 206 by 840. Why 840? Because your sample size is 840, which is 0.245. Q is 0.755. What is the standard error? Root PQ by N. So substituting, you get 0.015. You have to find the probable limit of families having income less than 2,500. That is P plus or minus 2.58 into root PQ by N. Substituting, you get 0.2063 and 0.2837, and you have to find the out of this 18,000 families, so you multiply each by 18,000. Why are we doing this? Because we have to find how many of these 18,000 families have monthly income of 2,500 or less. So multiplying, you get 3,713 to 5,107 after rounding it off. So many families have income less than 2,500. So we have seen how to calculate the probable limit standard error and how to check if a particular hypothesis is unbiased. Thank you.